Determine the word size sometimes can be so very difficult, but in this video I'll do my best to make you understand how we can determine the word size of a bracket using these two questions, right? Yeah, so in this question we have um this is two word and this is three, right? We have the three word, right? So then the question is asking us to find what from A to H, right? So I will encourage you guys to pause the video and write the questions down so that you can go with me whilst I'm explaining. So then let's go to the question. The bracket shown in figure 1, both of them are figure 1, is to carry a load of P, which is 90 kilonewton, treating the word as a line. So we are treating the word as a line. That means that we are going to apply it when finding the word area. That is where we are going to apply that. So let's get into it. So we are going to take this question, right? This is question figure 1. There are two questions, so I'm taking this one. So the first question is asking us to determine the distance from the centroid to the point of combined stresses. Now, from the centroid. So the main thing is that we should be able to determine the centroid of what this worded portion, right? So then we have a table that we compare. That's the properties of what the word treated as a line. So then we go back to it. We should first identify it, sketch the word. We should sketch the word. So we sketching the word, you know that the word will be this and this and that. Then we go back to the table. Then we identify it on it. As you can see, where can we locate that? This, not this, not this, not this. We know that is this, right? We can locate it from here. Then with that, we know that if we finding the centroid, it has been given to us, right? That is b squared over 2b plus d. That would be the centroid. So the centroid is this. This distance from here to here. That would be the centroid that we are finding, right? That is we finding. So then after getting that centroid, we are finding the distance, right, from the centroid to the combined forces. So where would the combined forces be? Actually, in this question, we have two stresses acting on this, which is the secondary stresses and the primary stresses. So with the secondary stresses, there are two secondary stresses, which can be the vertical or the horizontal. And with the primary stresses, it's only one, which is the vertical what? Stresses, right? Yes. So when there's a force applying here, right? There's a load here. You know that this is going to what? You're going to have a primary stress, and also there'll be a twisting moment, right? Yes, that's the secondary stress. So let's go into it. So how do you determine the um the centroid? So we're using this formula, which is what we've identified: b squared over 2b plus d. Let's note this side becomes a b and this side become what? The d. So when in this video we are going to just do some substitution and get it. So then we are supposed to find the distance from the centroid to the combined forces. Let's note that the combined forces was it here, right? So we're drawing it. We need to draw this to come here. To the centroid will be this, and then this will be here, right? So what you are supposed to find is that we are finding this distance here. That is, I'm saying this to be CH, and this will be what? CV. That's what I'm doing, right? So I'm using my letter to be here to be CH and CV, which represents the distance, the vertical distance from the centroid to the combined forces, and this is horizontal distance from the centroid to the combined forces. So how do you find that? Now, after finding the centroid, in this case, when we find the centroid, you can testify that b squared over 2b plus d, which will be 125 squared all over what? 2 times 125 plus 250, you're going to get 31.25 millimeters. That is the distance from here to here, which is 125. Then what will be the distance? No, we know that from here to this distance is what? 125. So for us to find our the vertical distance from the centroid to the combined forces, we are going to subtract the 31.25 from the total distance, which is 125, and we know that we get the vertical distance from the centroid to the combined forces to be 93.75 millimeters. The same thing apply to us. For us to find the horizontal distance from the centroid to the combined forces, we are going to do that. This is it. So how do you do it? Is a half of this. So note, you are just going to divide this by 2 to get the distance, because you can see that is a half of this. Always note, when a question is given to you, always with the vertical, you just divide it by 2, which represents the what? The horizontal distance from the centroid to the combined forces. As very simple as that. Now the next question is asking us to find the polar moment of inertia. With the polar moment of inertia, it's very simple. You go back to the properties of the word treated as a line table. Then you go back to where you've identified. This is where we identified, right? Then we know that our JW is given as what? 2b plus d all cubed all over 12 minus b squared that. So you're just going to do that and just do a substitution whereby you put the values inside. You know that this is our b and this is our d. What you do is what? Substitution. And at the end, you're going to get 60221350.417 millimeter cube. Please note the unit is millimeter cube, right? That is the polar moment of inertia. Very simple. That is from the properties of word treated as a line table. Then the next question is asking us to find the word area. The word area, note that we are treating the word as what? As a line. So in this case, you're just going to add this distance and add this distance, right? So therefore, you're going to get 125 millimeters plus 125 millimeters plus 250 millimeters, and which will give you 500 millimeters. As very simple as that. That is the word area. The next question you are supposed to find is that you are finding the horizontal components of the twisting right? That's from the question. That's the horizontal component. That's the twisting, right? So with that, with our horizontal component of the twisting, what you need to know is that the formula will be taken from the standard design formulas used for determining force on weld. So this formula sheet that will be given to you, you just go back to the twisting, and which is we are finding the what? The twisting, right? Which is with TC over JW. The T here represents the torque, which is, you see, when there's a load coming here, we are finding the distance, that is the moment. We are creating a moment at the centroid. So when it comes here, the perpendicular distance will be what? 250 millimeters. So then we are going to multiply the force, which is, or the load, which is 90 kilonewton, times the perpendicular distance, which is what? 250 mm, then times the CH that we found, right? That is the horizontal distance from the centroid to the combined forces. Then you divide by the what? The polar moment of inertia, and that will give you 467.02 Newton per millimeter. In this case, it's very simple. Sometimes in some questions they must extend this one. They're going to give you the total distance from here. So in that case, you just send what? Subtract the distance here from the total distance, then you get your what? Your E. Mostly the T is equal to the E, which represent the distance, times the what? The load. And at the end, you're going to get this, right? So the horizontal component of the twisting force, or the twisting, will give you this, which is TCH over JW. The vertical own too is going to give you TCV over JW. So the more aspect is that you being able to find the CV and the CH will help you with the calculation. That's very important, right? Now, with this, we are finding the vertical. We first established that we had our CV to be what? 93.75. So then our T is equal to what? The force or the load, which is 90 kilonewton, times the perpendicular distance, which is 250 mm, times what? Our CV, all over our what? Polar moment of inertia, which will give you 350.27. The next question you're supposed to find is that we are finding the vertical component due to shear force, right? The vertical component due to shear force is the same as what? This is the formula we're using. Is the same as the primary forces, right? Or the primary stress. In this case, we have our load to be what? 90 kilonewton, then divide by our what? Word area. So when you get a word area wrong, it means that your vertical force, that's vertical stress due to the vertical component due to shear will be wrong, right? So then at the end, we are going to get 190 Newton per millimeter. And I hope this is very simple. Then we finding the actual resultant forces. You are going to what? First, what you do is that you are going to take the horizontal component due to twisting, you square it, then plus bracket open. You are going to sum the vertical component, which is the what? It comprises of the what? The vertical component due to shear force and the vertical component due to what? Twisting. Then you square it. So when you do that correctly by substitution, you are going to know that you are going to get 706.61 Newton per millimeter. In this case, this is what? The vertical component due to shear force, and this is what? The vertical component due to what? Twisting. So then that is your J. Then our last one is for us to find the word size, right? So we finding the word size, what you need to do is that we are going to take the actual what force all over the allowance, right? In this case, the actual force we are going to use is our TR that we found, right? Then the allowance will be given to you in the question. Let's read the question. Let me go back to the question. It says determine the required word size. Assume word stress for 60 18 electrode is 135 megapascal. So in this case, the allowance stress, so it will be allowance stress, right? It's allowance stress. Allowance stress will be 135 megapascal, and the actual stress will be 706.61 megapascal. So the megapascal, they are going to do some cancellation, and then at the end we are going to get that our word size will be 5.23 millimeter. So this is very simple. Now let's take the next question. In this question, the word is in two ways. We don't have three words, right? So in this case, what you're supposed to do is that the whole idea is that first you need to indicate your triangle, then indicate this. So in your triangle, this become your CV and this become your CH. So then you need to find this distance, right? You need to find this distance. And in this case, you go back to the table. When you go back to the table, this is 2, right? So with 2, where can we locate the 2? This one. This is the 2, right? So in the 2, how do you find the centroid? For the centroid, you need to, for us to find this distance, right? You divide this one. When you get the 2 ways, you divide this one by 2. So this distance will be divided by 2. That will give you the distance. So you are going to take 127 divided by 2, which will give you 63.5. So this distance will be 63.5. Here will be 63.5. So then what will be the distance? Because when they give you this way, you're going to divide it by 2 to get this distance, right? So, but we know that with this distance, you're just going to divide it by 2. So then you're going to divide 245 divided by 2, which will give you 122.5. So when you get these questions, for the first one, the finding the centroid formula was given to us for us to do it very simple. But with this, it wasn't given to us. When you get this way, you are going to divide this word into 2, then you get the distance from here. So as far as you divide it into 2, when you subtract it from 127, you are going to get the distance, which will give you our CV. And our CH, you are just going to divide the 245 divided by 2, and you get our CH. Then you can continue with the what? With all the question, because we finding the polar moment of inertia, we'll get